Welcome to this month's meetup. This month is June, and I think first of all we have to thank our host for tonight with music. Yeah. Give them a round of applause. Yeah. So our first stop is going to be by Chris. It's
going to be deploying Rails on Amazon AWS OpsWorks.
Yeah, cool.
Via Chef. From Chef.
Whatever you're ready.
Okay, so the topic is this. It's basically about deploying a Rails application in AWS OpsWorks. Let's see if I can pull this up. So the big question to those who are unfamiliar with this service is what is it? Well, it's an application management service that allows you to organize your infrastructure and deploy easily on their platform. So basically, you're in charge of what components you need, either a relational database using Postgres, MySQL, and you can configure your instances. You can also configure it to work with other components such as CloudFront, which is AWS's CDN. There's Elastic Cache in case you need a NoSQL solution like Redis or a caching solution like Memcache. There's several other components out there, but I've just named a few. OpsWorks is also known to be a IaaS, infrastructure as a service. So compared to other deployment solutions like Heroku, Microsoft Azure, AWS has another solution called Elastic Beanstalk. They differ slightly differently. So let's say Heroku is more a platform as a service solution, so is Azure, so is the Elastic Beanstalk, and then there's another one called Contramix, which we'll see in the next slide. All right, so OpsWorks basically has two primary components to get started. It's fairly easy to understand what they are. First is a stack. So a stack basically represents your underlying set of, let's say, technology like applications. So basically in your stack you can configure, this is the part where you try to hook up your RDS or your other database solutions. Layers, and basically is how you define or set your instances. So in the layer so your stack can basically consist of, at least in Music, our stack consists of 3 layers. One is the back-end layer, the cron layer, and the front-end layer. The back-end layer would basically be in charge of handling your background jobs. So if you're using Rescue or Sidekick or some other solution, those instances would take care of that for you. And then your cron, which is most likely to have only one instance running in the back. You'll see all this in the dashboard a bit later on, like the practical demonstration. Would be on the cron layer, and then your front end is basically where the expensive part starts to happen. You get an influx of traffic. That means you have to scale up your instances in the front end. I.e., one instance. So in Music, you can have up to 20 instances running, depending on who's launching. You can also configure your instances to run on different web servers. So at the moment, OpsWorks supports Unicorn and Passenger. So in Unicorn, you can configure one instance to run 5 threads because it's a multi-threaded environment. So that essentially means that one instance can handle 5 concurrent requests coming to the application at one time. Okay, so I spoke briefly about the alternative deployment solutions. They're program. I'm pretty sure there are others out there. But it'd be nice also to see what the crowd is currently using for your deployment solutions. Does anybody want to share? Go ahead. Yeah. What's your name? How do I come to your?
Gerard, I'm a student of DLSU.
Okay.
Azure.
Azure. Rails on Azure. Okay, great. Do you know the cost? What are the costs like per hour?
We won it for BizSpark, so.
Okay. Okay, so it's like free for a year or something like that.
Yeah, 3 years.
3 years. Wow. Okay. So actually, Amazon, if you're signing up for the first time, allows you to use their service for 1 year on their free tier plan. I don't work for them, okay, so I'm not trying to convince you guys to use them. But I've met some of their business developers. They've flown here, and if you guys are willing to or wanting to connect with them, I can make an introduction for you guys. Anyone else wants to share? Heroku? Anyone still on Heroku? I know Terrence is still on Heroku. I'm just kidding. Heroku is a good service. Don't be shy. Like just share. Just say it. DigitalOcean. Okay. So that's more like you manage your VPS, right, from the ground up. You start with something really big. Yeah. So I think before solutions like the Elastic Beanstalk, CloudFormation, OpsWorks came out, you could still do what you're kind of doing with solutions like what DigitalOcean can offer you, but through their EC2 instances. So you would sign up and you configure all that for you. But the good thing about an infrastructure as a service or a PaaS is these are managed. So you end up spending more, but then you can also focus on your development. As a programmer, that's what you want to kind of do. So there are some like give or takes with this approach. Obviously, deploying in DigitalOcean will cost you a lot less than Heroku. Just giving you an idea, I think if you run around 8 or 10 instances monthly on Heroku, you're already spending $1,000 US because it's $36. I think it's $36 a month, right? Zero. Yeah. Anyways, I have the calculation on the next slide. Anyways. All right. So what I like about OpsWorks so far, besides the things I already mentioned, is the good thing. Just to give you a brief background, Twit Music was running on Heroku before, and we liked it. The support was great. It really gave us we didn't have to like spend any time on sys administration. It was like pure development. We had a problem with our deployment issues. Sometimes Heroku part was not perfect. Sometimes some instances will go down. They shoot you an email. They're ready on standby for email, chat. They have a great forum. They have like great. I know one thing I'd probably say that's good about Heroku is the documentation. It's really well structured. AWS OpsWorks is like looking at, or maybe AWS is looking at like it's an encyclopedia. It's just full of text, which is good because the information is there. But I just feel that sometimes they could maybe organize it a lot better. Yeah, exactly. So the good thing about OpsWorks, I can SSH into the instance. With Heroku, that was a bit limited. With Heroku, I could get into Rails console, but I couldn't get into the instance itself. And then I could also do Heroku logs, which basically allows me to access the application's logs. But I feel like I have more control with OpsWorks. So the other thing is there's scale automation based on load or time, so you can set your OpsWorks stack to react depending on the traffic that comes in or on the time of the day. It runs on Chef, which is great because Chef is a cloud infrastructure automation framework written in Ruby, so you don't have to learn. Although Chef the service is steep learning curve, but once you get going, you don't have to like know Chef. You don't have to be an expert in Chef to start using OpsWorks. You can already start using basic recipes. In fact, the Chef website has recipes that people commonly use, so you can eventually use those too. You don't have to write your own. And you have a great variation of instances available to you. So in Heroku, I think there's 3 now. There used to be 1. In Heroku, you have the option of deploying with instances with 512 MB, and then now just last year or something, they offered something with the 1 GB, and now they have a more optimized instance that you can choose. run your application on. Obviously, the higher instance you choose, the more costs you'll incur. But with OpsWorks, you actually have more. So you have like T1 micro instances, T1 small instances, medium, large, and then you can also choose instances that are more like memory optimized, or I think memory optimized and some other options there too. All right. Great, and the good thing about going on AWS is you have other options to other components. What's that? It's a Christmas song. Okay. So again, so you're already on AWS. You can integrate the other components that AWS has for you. Elastic Cloud Front, RDS, S3, their DNS server, Route 53. If you want to get into big data, there's that for you too. If you want to archive your data, there's also that option. I forgot what the service is called, but they're there. Yeah. DynamoDB is the big data database. And if you, anyways. And you have great support. So if you, the premium support that they offer is basically you pay them at least, I think it varies, but if you avail of this, you can get on them via chat. They can even, if you request for them to call you, they can call you in your profile. So, you know, for critical applications that are running and you have a client that's on standby, once this issue fixed, and if it's a deployment issue, they're right there to help you out. So this is the pricing I was talking about. So you eventually start out with a T micro instance. This is the smallest instance that you can deploy with. It's only good for testing. In fact, once you push it to production or more a production stable website, what happens is this isn't very stable. But just to give you an idea, this will cost you around $14 a month because they charge 20 cents an hour. The M1 small instance is more for like more serious applications. In fact, if you deem your application to be stable, I would recommend skip the T1 and go to the small instance. So you see it's like $31 difference, 31 compared to 36 for Heroku, that's a few dollars off. But again, you already see that the benefits there is the memory is almost 3 times higher than what Heroku offers for the same price.
SSD storage.
What's that?
SSD storage.
S3 storage.
SSD.
I think in the medium, that's when it becomes SSD. So, yeah. With Heroku SSD.
We're just comparing it to DigitalOcean.
Well, yeah, digital is all SSD, right? How about Azure? Can you like, what about Azure?
Amazon has like the new generation. So for example, for the compute optimized, C1 is not non-SSD, but the C3 are SSDs already. And then M1 and M3, so they have a new generation of instances that are...
So they're slowly moving all their instances into SSD, right?
Yeah, so I think they're starting to call the old types of instances as classic, but you can still spawn new classic instances.
That's good, no, that's good to know. Okay, I don't know how much time I have or how much time I've been speaking, but this is the end of my slide. I can show you a quick demonstration of what setting up a OpsWorks stack would look like for your Rails application. I kind of did it already because it takes a while to spin up OpsWorks. By the way, are you using OpsWorks?
No. I work for engineers.
Okay. So there's another solution. I forgot to mention engineer. This is also very beautiful. I did not deliberately mention. So it does take a while to spin up, and it says this is the only thing I have gripes with because let's say if like we demand instances, they really take a while because it has to run the asset pipeline in the background. I think Heroku does something for that. If you run the asset pipeline once, the precompile assets once, I think they cache it in some ways, but it runs the second time it runs, it's going to be a lot faster. Alright, so I think this is the stack I was talking about. Just the settings here. This is actually where you can set your custom JSON. So yeah, I'm not sure if I should show the database. Let's record it. So, Brian, like you'll burn that up. I'll just probably change it after. And then these are your layers. So again, it's a simple application. It's not even a blog application. It's a Hello World Rails application. Everyone can see this, right? So I have a welcome controller. I have a pages controller, which basically has the home method, and in this is just a hello world. But I made this a little bit different because I wanted to show you that I could set environment variables straight on the stack itself. So when I push, I don't push with my end file. I set my environment variables on the OpsWorks dashboard, and then it takes over, which is a good thing because the thing is you don't really want to share production. Yes, the tokens, secrets, passwords with non-critical or core team members, right? It's just, it's not that you don't trust them, but they might misuse it, and then it creates it makes a mess. Anyways, it's just good to separate that. What else do I have here? So, yeah, and so. Simple application, there's not much else to show, but the important part here is your chef cookbook. So this is similar to what these recipes are similar to the recipes we're currently using for our music staging and production environments. But once you've made your chef recipes, once you've coded them in a universal manner, you can reuse them. You don't have to touch them anymore. Basically, you just pass whatever JSON values you need on your dashboard, and your chef recipes, they do that for you. I mean, just to give out an example, let's say for my Rails application, I need a system library file called Node.js. You get that error with exec.js complaining no JavaScript runtime library can't be found. So the best thing to do on your OS X laptop or any other laptop is to install Node.js, and then you can deploy. You can bundle, or you can precompile. But that's the first thing you need. So in my, let me see. Give me a second. So I can't scroll down, like up to there. Okay, that's how your custom JSON can look like. Your chef recipe would go through all this. In fact, I have my database defined here, only because at the moment OpsWorks does not integrate fully with Postgres. It does with MySQL on RDS seamlessly, no issues there. But for this to work, I had to basically define my endpoints. Maybe I can scroll one more line down. Yep. Oh no. Whatever. It's our staging environment, so we can change it. But anyways, on that structure, you'll see a RDS endpoint that points to your Postgres RDS instance. But more importantly, you also not necessarily for Mac users, but more for, let's say, Windows or Linux. Your Rails application might complain about some Postgres libraries not being installed first. So here you can actually define it there. And then if you're using ImageMagick, you're using the ImageMagick gem, you need that library installed first in your system before you can actually use that. You can also go ahead and install that, and then the Node.js is there. So this is a simple JSON, but for ours, we've actually in our production, this is actually quite longer than what you see here. In fact, we store our end variables here too. Right, so, I mean, let's see, what else can I go through here? Yeah, so you have your stacks, you have your layers, and this is where you define your instances. So in the event, you can pre-create instances. You don't have to run them. The minute you run them, you get charged, but you pre-create them because they're already there with the configurations that you set them for. So like M1 small, optimized, compute, memory optimized. You can just click start and they run. So these are all your instances that you can choose from. They have the general purpose, current generation, previous generation. This is the one you mentioned, the M3, the M1. So I think the M3s are, what's your name? Mikong was saying that M3 are SSD, which is great. M1s are just still traditional hard drives. And then you have the optimized, compute optimized instances, memory optimized, and storage optimized. So like, I'll just go ahead and add a micro instance to my front end because I know like our app is gaining traction and I need to serve out these requests faster. That's what I'll do there. And it stopped. So I mean, I still have to add this instance to my main layer, which is the REST application layer. So when I'm ready, or when I need to, I can just click start here and just start. So it actually takes a while. And then once I realize my application matures a bit more and I realize, hey look, it's time to run background jobs, because I don't want to run everything on the front, right? I add a new layer. These are the predefined layers that OpsWorks gives you, but since we don't need any of this, we can set a custom layer and call this layer the background and give it a short name so it can identify itself with the rest of the application. And there you go. So now I have 3 layers. The main layer, which is the Rails app server, background layer, and then the front end. If I go to my instances, I have none yet. I can assign one here. And I can select the T there. That's basically it. So as soon as your application has something like Redis, Rescue, or Sidekick, or other layer job, you're good to spin this up, and it can start serving things from the background. Yeah, I think that's pretty much it. Unless anyone else, you can also set permissions. So permissions you do via IAM. That stands for. Wait, hang on. Let's Google it. So anyways, but once you have your IAM set up for your users, you can actually have them and grant them permissions to the extent of whether these users can SSH into the instance or just sudo into it. Actually, I think giving them access to this also means they can view this dashboard here and start instances from the dashboard. Yeah, identity and access management. Yep, I think that's it. Great. And I mean, the other thing I didn't really mention yet is the way OpsWorks or AWS monitors its resources. With Heroku, you couldn't really see that. So here with AWS, you can check like how many connections are hitting your database, how much space it has available, and they give you like all these nice graphs. It also alerts you when, let's say, a memory limit has been hit. It warns you also when you need to upgrade. And so a lot of the infrastructure or the components they provide is more transparent in that sense. Okay, that's it for me. That's good. Any questions?
Does it support other similar tools to Chef, like Topic?
No, it's just Chef at the moment. Yeah. In fact, you can select your Chef version, but nothing else.
It's one layer, let's say, possibly background layer.
Correct. So actually, that's a very good question. I haven't mentioned that yet, but so when you have a layer, you also have another instance called the Elastic Load Balancer, a load balancer, and you basically fit. So for Tube Music staging, yeah. I mean, for staging, we obviously don't need more than 2 because it's just a test environment, right? But you would set a load balancer here, and basically this determines where to route the traffic. If the instance is handling too much, it'll route the traffic to the instance that's handling a lot less. So basically, when you set up your DNS server, you make it. You see how like all these instances have IPs. You don't make your DNS server point to the instance's IP. You make it point to the load balancer's IP, and the load balancer will be in charge of routing the traffic to the other instances. Yeah, but that's good you brought that up. Okay, look, yeah, let's see. So what else? That's it. I mean, monitoring. Yeah, so this is what I was talking about. It really gives you like to speak. They have something called CloudWatch, which is I think this is more for OpsWorks specific. CloudWatch really gets into it more detail. These are the other components I was talking about that you can eventually integrate into those applications. So Elasticache for caching, Redis, Memcache is in there. CloudFraud, CDN, CloudFormation is even more. If you're more into SysOps stuff with deployment, CloudFormation might fit your needs. In fact, you define everything in one file and then you feed it to CloudFormation. It runs everything based on that one file. Elastic Beanstalk is the one that comes closest to Heroku. Yeah. That's it. All right. Any questions? Good. Okay. Great.